Hi dear students, welcome to the next part of the question discussion. So last class we have discussed till question number 22 and today we are continuing from question number 23 onwards, right? Okay, so question number 23. Okay, you can see the question. Identify the wrong statement in the following. Coulomb's law correctly describe the electric force that. Okay, we know Coulomb forces are exist between the charged particle. If it is one charge is positive, another charge is negative, Coulomb force exists. Or both charges are negative, Coulomb force exists. Or both charges are positive, Coulomb charges are exist. In short, Coulomb forces are exist between like charges and Coulomb forces are exist between unlike charges. Okay, now here we will analyze each of the statement and we need to pick the wrong statement in the given option. That is the intention here. Binds the electron of an atom to its nucleus. Okay, so binds the electrons of an atom to its nucleus. So we have a center part nucleus and we have outer orbit and electrons will be here. What is the charge of this one? Positive. What is the charge of this one? Negative. So it is like charges or unlike charges? Unlike charges. So what is exist will be here? I know Coulomb force exists. So that is a correct statement. Second one, binds the proton and neutrons in the nucleus of an atom. So when come to the nucleus, and this nucleus will contains neutron plus proton. So there is one force which is called nuclear force. Nuclear force is actually binding the neutrons and protons within the nucleus. Nuclear force. So the nuclear force is, so here the charge of neutron is 0. Here the charge of proton is positive. So there is no Coulomb force exist between them. Instead, what forces exist? That is called a nuclear force. So nuclear forces exist, not Coulomb force. So option B is a wrong statement and that is a correct answer for question number 23. Question number 23 is asking which of the following is a wrong statement. So answer is B will be here. We'll analyze the next two options also. Binds the atom to form a nucleus. So if I have one atom, A1, I have another atom, and these two combines to form a molecule, for example. Okay, a combines to form. So this contains neutron, proton, electron. This contains neutron, proton, electron. So proton to proton, Coulomb force will be here. Proton to electron, Coulomb force will be here. Electron to proton, Coulomb force will be here. Electron to electron, Coulomb force will be here. So whenever a charge interactions are possible, positive to positive, negative to negative, or positive to negative, then Coulomb forces are exist. But whenever a neutron with proton, no Coulomb force. Neutron with this electron, no Coulomb force. This neutron with this electron, no Coulomb force. This neutron with this proton, no Coulomb force. So electron to electron Coulomb force, proton to electron Coulomb force, proton to proton Coulomb force will be there. Which means, in short, if two atoms combine to form a molecule, then in that case Coulomb forces are exist. So here what type of force will be there? Coulomb forces. Coulomb's force will be here in this case. Okay, we'll look into the fourth option. Binds atom and molecule together to form a solid. Atoms will bind and will form molecule. Molecule will bind together. Multiple molecule will bind together and will form solid. So if there is a force exist between atoms, a Coulomb force, then there is a Coulomb force exist between the molecule, then there is a Coulomb force is exist within the solid also. That is also a correct statement. So for 23, answer is B. That is a wrong statement out of the 4 options given to you. So let's move to the next question, question number 24. Question number 24. An oil drop of radius r and density rho is held stationary in a uniform vertically upward electric field. If rho 0, which is less than rho, is the density of air and E is the quanta of charge, then the drop has. excess electron and deficiency of electron, which means we need to find out the number of electrons. We'll first represent the diagrammatic representation of the question. What is given? We have an oil drop will be here and which is held stationary in air. Means what is the downward force? mg. They mention an electric field will be there E in this direction. If an electric field will be here, and if the charge is a positive charge, then the electrical force is in the same direction. Okay, if two forces are acting in the direction, here F is equal to what will come? QE will come in this direction. If two forces are acting in opposite direction and they are equal, then in that case this oil drop is under stationary, which means it is not moving. Here it is not moving, that is given in the question. So that is clear to us, right? It's not moving. So in that cases what we can do? It's not moving. Suppose if it is negative charge. If it is negative charge means F is equal to minus QE in this direction. So I have to say F is equal to QE in this direction if Q is negative. So in that cases QE and mg both are what kind of? Both are acting in the same direction if it is negative. If it is negative, this will be like this. Both forces are acting in the same direction. If both forces are acting in the same direction, is this body will come to equilibrium or will come to stationary state? No, it will move downward. So negative charge will not be possible. Definitely it should be a positive charge. Positive means what? Gaining the electron or losing the electron. Positive means losing the electron. I am a donor here. I am losing the electron. So there is a deficiency of electrons will be here. So deficiency of an electron is the right answer. So deficiency of an electron will be comes with the option C and D, and we have to decide what is the right one. Okay, so in that cases the body is to be in equilibrium. We are saying QE is equal to mg, Q is equal to Ne into electric field, M equal to mass equal to density into volume. So effective density is rho minus rho 0. Rho is the density of that liquid and rho 0 is the density of air. So now this is an air medium. So the effective density means density of that material minus that of air medium, because it is in a medium. Into, so density into volume. Volume means what? 4 by 3 pi r cube into times of g. Here we have to find out the value of n. So n will be equal to, tell me, rho minus rho 0 times of 4 pi r cube g whole divided by 3 times of E. This will be the right answer, and this is matching with your option number C. Option C is the right answer for question number 24. Okay, hope you understood. So why we have come to a conclusion of deficiency means it should be positive, then only the forces along the direction of electric field. If it is negative, then the force is opposite to the direction of electric field. So it should not be negative, it is positive. Positive means a donor. I am donating some electron, which means I am losing some electron. Losing means deficiency. That's what we come to option C and D, and also we find the correct value, and by combining these two answers, we will come to an answer of option C. We will move to 25th question. Okay, 25. Okay, what is 25th question then? A square surface of side L meter in the plane of the paper is placed in a uniform electric field. Volt per meter is given, acting along the same plane at an angle theta with the horizontal side as shown in the figure. Okay, the electric flux to the surface in unit. Okay, we'll draw the diagram. So this is the diagram which is given, and this is the direction of electric field. Electric fields are acting like this one, and with respect to this horizontal surface, for example, with respect to this horizontal surface, it makes an angle equal to theta. Here electric field is in this direction. This is a plane sheet. Okay, so for this plane sheet, what is area vector? Area vector, I can say two ways. On this plane surface, the surface which is facing to us, the area vector is coming outside like this, towards you, towards this you. Okay, so it is towards you. The electric fields are coming towards you. So electric field, the area vector is like this. This is called area vector. Area vector is perpendicular to the surface. So area vector and electric field, what is the angle between this black line and my pen? This angle is 90 degree. Correct? The line is like this. The line is like this. And area vector is like this. So what is the angle? 90. So what is the definition of flux? Flux will be equal to closed integral E dot dA. I can specifically written as E into dA into cos theta. Theta is the angle between electric field and area vector. Area vector is like this. Electric field is like this. So angle is 90 degree. So 5 into E dA of cos of 90. So answer will comes as 0. So here, just to confuse you, they are giving the value of theta. Theta is what? Theta is an angle making with the horizontal direction. That is not the area vector. Area vector is always perpendicular to the plane. So angle between electric field and area vector, that is 90 degree. So there is no flux. Flux will be equal to 0. So always be alert on the question. This is just to confuse you in the question. Okay. So small tricky things they are introduced to have a negative mark for you in the examinations. So be careful such kind of question. 26. Okay. An electric dipole moment P placed in uniform electric field has minimum potential energy when the angle is how much degree. So that is a question for 26. Minimum potential energy will be happens. So we know the equation of torque. Torque will be equal to P cross E, or this is equal to PE sin theta. This we have learned. So now we are going to learn one new concept which is called potential energy. Potential energy is integral of PE sin theta. Okay, energy. Okay, here it is called potential energy. Potential energy is equal to integral of P sin theta into d theta. This is something like energy in our first year we have learned about, right? Instead of U, in first year we have learned about W and integral. We will learn, this is called a torque. Okay, so instead of torque, this is called torque and d theta. So instead of torque, what will come will be here linear motion F dot ds will come. F into ds will come. Okay, so PE sin theta integral F ds. This definitely you have learned on your work power energy chapter from first year physics. Okay, work power energy chapter, you have learned this concept from work power energy chapter. Work is equal to integral F ds. Either instead of F torque in rotational motion, or in case of a rotational motion, instead of F torque, ds is a linear displacement. Here it is angular displacement, so it is d theta. So once we integrated this one, what will get? P is constant. What is the integral of sin theta? Minus cos theta. So it becomes cos theta. So here question is asking at what value this potential energy is minimum. If you see here theta equal to 0 degree, if you take, what you will get? You will get potential energy is equal to minus PE. This is the most negative value or most minimum value you can achieve when theta equal to 0 degree. So if you look into the option, theta equal to 0 is the right answer. If you give pi by 2 will be here. Option B is given pi by 2. Pi by 2 if you substituted here means what you will get? 0. 0 is greater than minus PE, right? And the third option is C. C means pi. If you substitute a cos pi means minus 1. So you will get plus PE. Plus P is also greater. And again 3 pi by 2. So that value is also greater. So the minimum value always you will get it when theta equal to 0 degree. Minimum value means most negative value. Okay. So minus PE, and this is happening because when theta will be equal to 0 degree. So this formula you have to remember. U equal to minus PE cos theta. Okay, put it in a box. We'll move to the next question. Question number 27th. Okay, 27th question. Okay, charge. Which of the following statement is incorrect? Wrong statement. We have to find it again here. Charge Q of a body is always Q is equal to NE. where n is any integer positive or negative. That is a correct answer. That is actually called the quantization theorem. By conservation, charges of an electron is taken to be negative. That is also correct statement. The fact that electric charge is always an integral multiple of E in terms of quantization of charge. Yes, integral multiple means positive, negative or any number. If you multiply it, you will get Q. Q is equal to NE. That is also another form of definition of option number A and option number C. Both are same, integral multiple. Last one, quantization of the charge was experimentally demonstrated by Newton in 1912. No, that is wrong answer. Quantization of a charge is experimentally demonstrated by a scientist which is called Millikan's. Okay, so you can write as a note, quantization of a charge experimentally proved by, experimentally demonstrated by, not proved by, demonstrated by Millikan's. Okay, Millikan is a scientist who created a model of quantization of charges. So option D is the incorrect statement, all others are right statement. So your answer is option D. Option D is a wrong statement. We need to find out the wrong or the incorrect statement. So we'll move to the next question. Question number 28. Two positive ions each carrying charge Q are separated by a distance t. If the force F is the force of repulsions between the ion, number of electrons missing from each ion will be, E is being the charges of an electron. So we know F will be equal to two positive ions each are carrying a charge is equal to Q. So there is a Coulomb force will be here, 1 by 4 pi epsilon 0 Q1 Q2. So Q square by, what is the distance between them? It is given as D square. Okay, now what they are asking? They are asking number of electrons, number. So how to get number? You know how to get number, right? 4 pi epsilon 0. Q is equal to NE. So N square E square divided by D square. N we have to find out. So first we'll find out N square. N square means F D square 4 pi epsilon 0 whole divided by E square. So N will be equal to root of F D square 4 pi epsilon 0 whole divided by E square. So this is the right answer. 4 pi epsilon 0 F D square by E square. Option C is the right answer for this question. F D square. Root will be there because N square is coming. So answer is option C for question number 28. We'll move to the next question. Question number 29th. Okay. Question number 29 speaking about two small metal spheres A and B have charges. So A metal sphere and B metal sphere, A and B having charges 4Q and minus 4Q when placed at a certain distance apart. Okay, let me consider this distance as small letter D. Exert an electric force F. So this will give an force equal to F on each other. When another identical uncharged sphere C is first in touch with A. So another charge C will be here which has no charge, which is in touch with A. So if this is first in touch with A, then what is the charges of A will be? A will be become 2Q and this will also get a charges of 2Q. First in touch with A, then later what will happen? First touch with A and then with B and then removed it to infinity. Then now after that this charge C is going to touch with B. Already it has 2Q charge. When it is touched with that body means 2Q plus minus 4Q divided by 2. So it become minus 2Q. So minus 2Q divided by 2. So it become charge is equal to minus Q. So this will have a charges of minus Q. During the time this will also have a charges of minus Q. So if it is touching means a total charge divided by 2. Okay, here it is earlier 4q, here it is 0. So 0 plus 4q divided by 2, 2q. Now it's got 2q. After 2q, it is touch on which charge? Charge number, the sphere number B. B will have always minus 4q. So 2q plus minus 4q divided by 2 minus 2q by 2 minus q. Now this is a charged conditions. So initially, what is the force of this one? The F initial is how much? F initial is equal to, F is given in the question 1 by 4 pi epsilon 0. Okay, F is given, F is equal to 1 by 4 pi epsilon 0, Q1, Q2 by, so Q1 charge is how much is given? 4Q. So it is minus 16 Q square by D square. Now what is the charge? F final is equal to 1 by 4 pi epsilon 0. What is the charge? Minus 2q square divided by d square. Okay, so I can say F initial equal to, if you compare these two, I can say F initial equal to 8 times of F final, or I can say F final is equal to F initial by 8. F initial by 8 means F by 8. F initial is given as F in the question. Okay, if you compare these two, this is 8 times higher than this one. That's what I would, F final into 8 is equal to F initial. So F initial by 8 equal to F final, which means F by 8 is the right answer for this question. F by 8, option number B. Option number B is matches with this one. Question number 29. Okay. Fine. We'll move to the next question. Question number 30th. 30. So hope you understood. You can pause the video and you can complete your notebooks accordingly. So this is a straightforward question. Sharing of the charges, which we have learned when we started the chapter, right? So this question is based on from the concept of sharing of the charges. Question number 30. 30. Electric field intensity just sufficient to balance the earth gravitational attractions on an electrons will be. Earth electric field intensity is just sufficient to balance the earth gravitational attractions on an electron will be. So an electron will be here. This will act, a force will be equal to, okay, this will, okay. So I can say an electron gravitational pull equal to, electron gravitational pull means which is equal to force due to electric field. Okay, force due to electric field means we have an electrons will be here and this will act a force, F is equal to minus EE force, and this force should is equal to mg. So minus EE in the positive direction, in the upside. So this should be equal to this one, then it will balance. If you're taking plus EE means it will downward, it will never balance. So this F should be always upward. So minus EE will be equal to mg. What they are asking in the question, sir? Electric field, E has to be final. So E will be equal to mg divided by minus electric field. M will be equal to mass of electron 9.1 into 10 power minus 31 is given. This is value 10. Electronic charge 1.6 into 10 power minus 16 coulomb, and this is negative charge. So if you simplify this one, what's the value you are getting? 30th. So two things will be there, and here electronic charge has to be taken negative, and 9.1 into 10 power minus 31 is the mass of electrons, and the G value you can take it as 10. 9.8 of course we know, but while solving the question's entrance point of view, you can take it as 10, and electronic charge 1.6 into 10 power minus 16. If you solve this, minus 5.6 into 10 power of minus 11 Newton. The unit of electric field, Newton per coulomb or volt per meter, any two units will be considered. So minus 5.6 into 10 power minus 11, this minus 16, right? This will go to numerator, become 10 power 10 power 16. If you simplify this, minus 5.6 into 10 power minus 11 Newton per Coulomb is the right answer for this question. We'll move to the next question. You can pause it and you can complete it. We'll move to the next question. Question number 31. So, question number 31. Okay, what is 31 is speaking about? An electric dipole is placed at an angle of electric dipole 30 degree with electric field. So, the angle between, so theta between, okay, so instead of theta I can write it as angle. So, the angle between P and E will be equal to how much degree is given? 30 degree. And the electric field intensity is given how much? 2 into 10 power of 5. It is given electric field. It experiences a torque. Torque is also given how much? 4 Newton meter. Calculate the charge on the dipole if the dipole length means 2L is dipole length is how much? 2 centimeter. We have to calculate the charge. We know torque is equal to PE sine theta. So torque value is given. We will substitute 4 equal to P means 2LQ into electric field into sine theta, sine of angle between them. So 4 will be equal to dipole length 2L is given 2 centimeter. So 2 into 10 power minus 2, Q has to be find out. Electric field 2 into 10 power of 5 and sine of 30 degree means 1 by 2. So these 2 and these 2 get cancels. And 4 and 2 get cancelled, it become 2. Okay. So now we'll simplify, we'll go and further simplify the next steps. Here we have 2 and right side we have 10 power minus 2, 10 power 5. So nothing will be here and we have like a Q into 10 power of 3. Okay, no other term, I guess I have not missed any term. 2 left side minus 2, 10 power 3 and Q will be here. So Q will be equal to 2 divided by 10 power 3. So which is equal to 2 into 10 power minus 3 coulomb, or I can say 2 millicoulomb. Okay, so 2 into 10 power minus 3 coulomb, or this is equal to 2 millicoulomb. This is given in your option number D. Option number D, it is given in terms of millicoulomb. So 31 answer is D. Option D is the answer for the 31st question. Okay. Okay, we'll move to question number 32. Question number 32. Okay. What is question number 32 specifying? A particle of mass m and charge q is rest in a uniform electric field E and then released. Kinetic energy attained by the particles after moving a distance y. Okay, question is simple. A particle of mass m, its charge is q, placed to rest in a uniform electric field. Okay, then it is released, so it is moving. What is the kinetic energy? So always energy. Okay, energy is equal to force into the distance traveled. Okay, normally if it is comes a term called kinetic energy, you may think like half mv square. Correct, because v is a velocity. But here we have no way to find out velocity. Okay, so kinetic energy means the energy attained by the body when it is moving. Half mv square is a correct expression. But here we have no way to find out v. So what we'll do? Who is giving the kinetic energy? Kinetic energy will be equal to, in this case, force into displacement, which is equal to kinetic energy half mv square. The distance traveled by the body with the help of a force F, and this is called F, that is called energy. That energy is converted into kinetic energy. So what is F? F will be equal to QE. Okay, what is the distance traveled? Y amount of distance the body is traveled. So kinetic energy will be equal to QE into Y. Answer is option C. Option C is matches with this one. So E is equal to energy. This is not electric field. Okay, you can put it as energy if you are getting confused. Energy is equal to Fs equal to half mv square. This Fs, force into displacement, that is called an energy, work energy, and that energy is converted into kinetic energy. Here we have no way to find out V, so this energy is equal to this energy. All energies are equal to each other. Okay, so 32 is over. Let's see 33. There is an electric field E in x direction. If the work done on moving the charge, so we will see an electric field will be there in what direction? Positive x direction. It is again positive x direction on electric field will be here. If the work done on moving a charge will be equal to 0.2 coulomb through a distance of 2 meter along a line making 60 degree with x axis is 4 joule. What is the value of electric field? This is what we need to be find out. An electric field will be there in the positive x direction and charge and 2 meter and be making an angle of 60 degree and work is equal to what? Of course we know, just before we have written, right, F dot S, which means Fs cos theta. Theta is an angle between force and displacement. We'll see what is the angle will be given, will be here in question number 33. Through a distance 2 meter along a line making an angle 60 degree with the x axis. 60 degree. So actually this is an electric field line, so which means force is also in the direction. And the body is moving a 2 meter distance by making an angle of 60 degree. So this is what is called our displacement, and this is called what is called our force. So the angle is given, we can substitute here. Whenever some angle are given in the question, do not take it blindly. Okay, if there are 3 or 4 angles, or depends upon the question, if some angles are given, we have to decide what is suits to our question. In this case, the angle between F and S, force is in this direction because electric field is in this direction, it's given as an int, and the body is moving a 2 meter distance, and which is making, you can see the question, which is making 60 degree with the electric field, which means the displacement vector is making 60 degree with the force. Now we can substitute, will be here. Energy is 4 joule is given. F will be equal to, we can substitute QE. So QE into distance into cos theta. Now we'll substitute 4 equal to Q value is given 0.2. Electric field has to be find out. Distance traveled is 2 meter and cos become cos 60. We'll simplify this. 4 equal to 0.2 into E into 2 into cos 60 is 1 by 2. So 2 get cancels. Okay. So the electric field will be equal to 4 divided by 0.2, which is equal to 2 into 10 power 1, which means what? 20 Newton per coulomb is the right answer. 20 Newton per coulomb. So this is matches with our option number D. Option D is the right answer for question number 33. So whenever some angles are given, be careful. Understand what is this angle mean. This is between force and displacement. In this question is a direct question. So it should not be always like this, like that. So always you have to remember what it is indicate and accordingly do it forward. Okay. So till question number 33 now we have discussed, we have to move to the further questions. Hi dear students, so we will continue from question number 34. A surface has the area vector A is given 2I plus 3J meter square. Flex of an electric field through 8 if the field E will be equal to 4I volt per meter. So we will list question number 34 we are going to discuss, and area vector A is given like 2I plus 3J and electric field will be given as 4I volt per meter. We need to find out flux. Flux we know closed integral of E dot dA, or we can say if you are integrating dA it become A, so we can written as E dot A. So we are doing dot product between these two. So the dot product between these two indicate electric field is 4I volt per meter, right? Area is given in unit of meter square here, meter square. Okay, so E dot A, dot product means we have to multiply I with I and J with J. There is no J with J, only I with I. So 4 into 2, 8. So answer is 8. So 8 meter square into volt per meter. This is a unit of this one. If you are to multiplying these two, we will get the unit of flux. But answer is here 8. So a surface area vector flux of an electric field, and this is equal to 8. So 8 Our unit is meter square volt per meter. This means meter square meter get cancels. 8 volt meter is the correct answer, and which is matches with option A. So 34, answer A. Direct questions, direct dot product. Dot product means I with I and J with J. There is no J will be here. So 4i and 2i multiplied will get 8. I into I is 1. There is no J. So J, 3J into here it is 0. So answer is 0. Okay. So total is 8. So total 4 into 2, 4 into 2, 8 plus 3 into 0. 3 into 0 is 0. So answer is 8. 8 voltmeter, option A for 34th question. We'll move to the next question, 35. Okay, so question number 35. It's a statement based question. There exists a non-uniform electric field along the x-axis as shown in the figure. The field increases at uniform rate along the positive x-axis. Okay, dipole is placed inside the field as shown in the figure. Which one of the following is the correct for the dipole? Dipole moves along the positive x direction and undergoes a clockwise rotation. So okay, we will see. So two things will be there. When a dipole is placed in a uniform electric field, it will experiences only torque and no force. When a dipole is placed in a non-uniform electric field, if it is uniform electric field, it will experiences only torque and no force. And if it is placed in a non-uniform electric field, it will experiences both torque and force. So our answer should contain torque is there, that is one part, as well as it contains something called force also. So here we need to find out torque, here we need to find out force. So first let's represent the diagram like this. So we have a field is directing in this direction, and this is on positive x-axis, positive x-axis. So x-axis positive, so it's a positive x-axis, and a charge is placed like this one. Here it is plus q, here it is minus q, which is makes an angle of alpha. So what will happen here? Electric field is in this direction. So F is equal to QE will be there, minus QE will be there. F is equal to QE in this direction. F is equal to QE along the direction of electric field. F is equal to minus QE in the opposite direction of electric field. So two forces will act like this. So as I told, while I am taking torque, if the dipole will be here and we have two force QE and F is equal to QE. So what will happen? It will rotate. It will rotate like this, correct? Tuck, 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 tuck. It will rotate like this because two things will be there. Bottom it is pushing and top it is pushing like this. So it will rotate like this. This is what kind of rotation? This motion. This is anti-clockwise rotation. So anti-clockwise rotations are there. Anti-clockwise rotation. This is one point. And second point, we know torque, the value of electric field is increasing in the positive x direction. So if you compare this force and this force will be, two forces will be here because of minus q, this force, and because of plus q. So the plus q and minus q position, if you compare, minus q is more in the positive side comparable to that of plus q. Okay, so here charges are equal, but electric field will be higher here. Electric field at this point will be lower because this is more towards right side. So it is more positive. If it is more positive means the force is also higher. This force is lesser. So what will happen? It will move towards in what direction? Negative x direction it will move. Okay, so torque, we can say torque in what direction? Anti-clockwise direction, and force is towards negative x direction. Hope you understand. This is a very beautiful question. There is a high chance to ask this question based on the concept. Okay, because of the non-uniform electric field strength at minus q point is higher than plus q, because if you are moving from left to right, electric fields are increasing. If it is increasing means at this point comparable to this point, high electric field. Due to high electric field, high force. So this is high force, this is less force. So what direction it will move? It will move towards left side. So we'll see the options. Dipole is moves along the positive x-axis is wrong answer. Dipole is moves along the negative x direction. Left side it is moving and undergoes an anti-clockwise rotation. So answer is matches with both of the conditions. Answer is your option number D is the right answer for question number 35. Let's move to the next question. Hope you understand. Okay. So if you have any doubt, of course, as usual, come back to me. We will discuss, we will make the points to be clear. Okay. So ultimate aim is you must to know the concept. 37th, right? No, 36th. Okay, 36th question, 36. A square surface of L meters in the same plane of paper, a uniform electric field volt per meter along the plane of paper, and is limited to only half of the square surface. See in the figure. Electric flux. Okay, so this is a similar questions what we have done previously also. We have an electric field will be there on the lower half. Okay, if it is upper half, lower half, no problem. Electric field will be like this. What is the area vector? Area vector is out towards you. So area vector is coming towards you. Electric field is like this. So flux will be equal to, as I told, E dot dA integral or EA cos theta. What is the angle between electric field and area vector? 90 degree. Cos of 90 degree. So answer is 0. Here they try to confuse you. What they try to confuse you? In this surface, they just unwantedly states that the electric fields lines are only present in the lower half. If it is present on the lower half, if it is present on the upper half, doesn't matter with the flux. Flux is always equal to strength of electric field into area into angle. So here angle is 90 degree. That's what the whole flux will go into 0. So answer is matches with option B. Option B is the right answer for this question. 36. We'll move to the next question. 37th. Okay. 37. We are approaching the end. 37. Among two bodies A and B, first have the radius 10 centimeter, charge 10 centimeter, and charge will be equal to, so the first body A will have a charge equal to 10 power minus 6 microcoulomb, and B will have a charge radius 30 centimeter and charge is equal to 10 power minus 5 coulomb. Here R1 will be equal to how much radius? 10 centimeter. Here R2 will be equal to how much radius? 30 centimeter. When they are touched each other, charge on both QA and QB respectively. So if they are touched together, means charge sharing will happen independent of the size. Now if you see, this is a bigger one, this is a smaller one, but this is a bigger one. That doesn't matter for us, will be here. Whether it is smaller one or a bigger one, doesn't matter. But the quantity of the charges will be also getting different, or it may be same. But if they are touches together, what is the total charge? QA plus QB divided by 2. Average charge will be attained the two bodies. 10 power minus 6 plus 10 power minus 5. Both are microcoulombs, right? 10 power minus 6 and 10 power minus 5 coulomb. This is in coulomb. One is in microcoulomb. Okay. So so we have to convert into unit. So 10 power minus 6 microcoulomb converted into 10 power minus 6. But what is the option is given? Option is given in terms of microcoulomb. So everything will make into microcoulomb. So we'll do one thing. This 10 power minus 6 will take in microcoulomb, and 10 power minus 5, this is in coulomb. How to convert into this into microcoulomb? We have, if you multiply it with 10 power 6, if you multiply this with 10 power 6, then it is converted into microcoulomb. So how will come? 10 power minus 6 plus this is 10. Okay, so we have to solve this one. So what we'll do? I'm taking 10 power. Okay, so 10 power 10 plus 10 power 0.1 means it's comparatively very less, right? So QA, both bodies will attaining the same charge. What will be the same charge? It is a sum of two bodies, and one is having QA plus QB, and the other one is also will having the same charge which is attained by these two bodies. There are no differences for the charge between the two bodies. Okay, so one is having 10 power minus 6 coulomb and another one is having 10 power minus 5 coulomb. So hold this body divided by 2, total number of charges will be here. So this will be answered with a 10 divided by minus 6. So approximately I can say 5 point something will come. 5 point something will come. But what is matches with these options? 37th 5.5 microcoulomb means approximately 11 has to come, minus 6 microcoulombs. So coulombs 10 power, so 10 approximately 5.5. Okay, here you will never get an exact answer, but it is slightly greater than 5. Okay, but both are in microcoulombs, so it is slightly greater than 5. Slightly greater than 5 means which is what is coming in that options. QA, option A will not, option B will not, option C will come. Option C will be equal to 5.5 microcoulomb. This is an approximate value I have written. If you solve it, you will get correct value of 5.5 microcoulomb. So only the concept is like, doesn't depends upon the ratio of the radius or the bigger or smaller, doesn't matter. Ultimate aim is what is the charge, and the charge divided by 2 is the each of the contributions. And also without doing this also you can answer. If you see like option A, there are 2 different charges. If a body will touches each other, there will not get any 2 different charges. Charges will be always same, because they will share the charges unless until they are equal. So QA is one value, QB is one another value. There is no chance to come like that. Both the charges are equal when they are touching each other. It should not be different at all. So option A and B are always going out. Option C will have a chance, or option D will have a chance. So either C and D. D is none of the above and none of this, and C is 5.5 microcoulomb. So C is our answer in this case. Okay, let's move to the next question, 38. So 38, we'll see what is 38 is speaking about. Total electric flux emanating from a closed surface enclosing an alpha particle, E is the electronic charges. Total flux will be equal to, as I told before, closed integral E dot dA will be equal to Q enclosed divided by epsilon 0. E is the electronic charge. Here question is speaking about what is called alpha particle. Alpha particle means, normally an alpha particle we have written as 2 helium, 2 He4. So which contains how many electrons? 2 electrons will be there. So 2 is the atomic number. So in case of for this one, flux will be equal to Q enclosed, means 2 electronic charge divided by epsilon naught will come as the answer. So this is matches with option A. So option A is the right answer for question number 38. Okay. So we'll move further to 39th question. What is 39th question is speaking about? Which of the following is a wrong statement? Charge of an isolated system is conserved. That is a correct statement. It is not possible to create or destroy charges. That is a wrong statement. It is not possible to create and destroy charges. A wrong statement. It is possible to create. It is possible to create and destroy charges in your small school classes itself. You may have learned, while I was in school, I have learned this one. Maybe you are also learned this in your schools. Normally, a very simple way. If you have your normal scale, your plastic scales with you, right? If you have keep on rubbing on your head, and if you have a small pieces of papers, if you keep it near, it will attract. It will attract. Why? Because electrostatic discharges will be happening, means charges are accumulated on this scale, on your scale, and when you keep it near a paper is an insulator, but due to the induction property, the opposite charge will be induces on the paper, and the paper particle, the small pieces of the paper is attracted towards your scale, which means there is a induction property is there, and as well as we have created the charge, and after some time if you put the scale again, no, it's not there because the charges are getting destroyed. So charges can be created, charges can be destroyed. Okay, it's not like a conservation of mass. In conservation, mass can't be created, neither be destroyed, can be converted from one form to another form. It's something like an energy. But here charges can be created. So the statement B is wrong. Not possible to create or destroy charged particle is a wrong statement. It's possible. Okay, so 39th answer is option B is the right answer for the question, because question is asking about the wrong statement. Wrong one is option B. We'll move to the next one. 14th question. 40th question. What is 40th question, sir? A charge Q is placed at the center of an open end of a cylindrical vessel. The flux of the electric field through the surface of the vessel is, okay, through the surface of the vessel with respect to the vessel alone. The vessel is an open surfaces. So what is flux? Flux will be equal to, while we are defining, we told flux will be equal to closed integral E dot dA will equal to Q enclosed divided by epsilon 0. In order to apply this theorem, I need a closed path. Any closed path will be here. It is already given, it is a cylindrical surface, and that cylindrical surface is an open surface. So flux will be equal to 0. Flux is equal to 0 because it is not a closed surface. You can write it is not a closed surface. It's not a closed surface. If this question is the flux of the electric field through the surface of the vessel, question is asking with respect to the vessel. So if you have considered that vessel alone, then flux will be equal to 0 because it is an open surface. We'll go to next question, question number 41. Okay, so question number 41. What is the question number 41? If the electric flux entering and leaving end surface equal to 6 into 10 power 6 and okay, so electric flux entering equal to 6 into 10 power 6. Electric flux leaving the surfaces will be equal to 9 into 10 power 6. Okay, then the charge inside the surface of permittivity of free space. Okay, so we know the total flux, I can say net flux will be equal to Q by epsilon 0. Charge we need to find it. Q will be equal to how we can written as epsilon 0 into flux net. Epsilon 0 into flux net. Epsilon 0 flux net means higher minus lower. You can take it like this one. So leaving flux will be higher than entering flux. So what is the total flux? 9 into 10 power 6 minus 6 into 10 power 6. So it is 3 into 10 power 6 into epsilon 0 is the total charge which are enclosed within the surfaces. 3 epsilon 0 into 10 power 6. This is matches with your option D. So your option D is the right answer for question number 41. So total flux will be equal to entering flux and leaving flux. Entering flux means if you have taken a closed path, what this is saying, like some number of lines are entering and some number of lines are going out. If this is phi 1, its direction is like this and its direction is like this. So with respect to this surface, if you are taking, some are coming and some are out. If phi E is entering flux and phi leaving is the exit flux, then what is the total flux inside the surface? Leaving minus entry or entry minus leaving. You can take it in any order, whichever come first will be the answer. Okay, you can take it enter minus leaving, leaving minus enter. So enter minus leaving minus enter means total flux is a leaving flux because leaving will be higher. If enter minus lower, if you are taking, means total flux nature is entering kind of nature. That's all. So always you can take lower, higher minus lower quantity, so that you will get the answer. We'll move to the next question, 42. Okay, 42. 42 question is speaking about two particles of equal masses and charge, equal masses m and charge are placed at a distance of 16 centimeter apart. They do not experience a force. The value of Q by m. If two particles are placed with a mass, then as per Newton's gravitational law, a gravitational force will be there, Fg. G m1 m2 divided by distance between them is 16. Anyway, it is centimeter square, so I just take it as 16 centimeter square. Okay, you can convert into this into SI. We'll convert this into SI system, minus 2 whole square. And we have an electrical force will be here 1 by 4 pi epsilon 0 Q1 Q2 by R square. Both bodies will have, so general formula Q1 Q2 divided by R square. But here it is saying charges are equal and masses are equal. So the formula will be like this one. So what is the distance will be here? 16 into 10 power of minus 2 the whole square. So it will not experiences any force means there is a two nature will be there. Gravitational force is an attractive force. Gravitational force means that is a force with respect to mass and it is an attractive force. But electrical force either may be attractive force or may be a repulsive force. But what is given in the question? They do not experience as a force, which means that what? Attractive gravitational force cancelled with which force? Repulsive electrostatic force. Repulsive means going away, attractive means coming inside. If both are equal, what will happen? These charges are in rest position. That's what we are going to do. So which means gravitational force equal to electrostatic force. So gravitational force G m square divided by the distance 16 into 10 power of minus 2 the whole square equal to 1 by 4 pi epsilon 0 Q square divided by 16 into 10 power minus 2 the whole square. Get cancelled these two terms. What we need to be find out? The value of Q by M. The value of Q by M we need to be find out. Okay. So we'll take this M to the right hand side. This M to the right hand side and we'll take. So G into 4 pi epsilon 0 will multiply will be here. G into 4 pi epsilon 0 cube. So Q by M, which means its root. So if you simplify this one, Q M will come to denominator, 4 pi will multiply here. So your answer is 4 pi epsilon 0 times of G. This is matches with which one? Option number D. Your option D is matches with the handout discussion question. Okay. So option D. 42 is over. We'll move to next question, 43. So we'll say 43. Okay, what is all about 43? A rod of length 2.4 meter and radius is 4.6 meter carries a negative charges of 4.2 into 10 power minus 6 coulomb spread uniformly over its surfaces. It's a rod. Electric field near the midpoint of the rod at any point on its surface will be. So here question is speaking about a rod. Okay, so this rod will be contain some charges. I need to find out an electric field at some point around at the middle position. So how to find out what is the electric field due to a rod? Can you tell me? We need to find out at a distance. We need to find out at a certain distances, and we have some parameters are given. What are the parameters? Length of the rod will be given. It is 2.4 meter and the radius will be given 4.6 millimeter. Okay, so 4.6 millimeter means 4.6 into 10 power minus 3 meter. This is one thing will be given. So all these parameters are given. We need to find out for this kind of rod, it may be what kind of nature. We need to find out the electric field intensity at a distance of R meter. R meter means along the center region we need to find out. So what is the electric field intensity due to a rod or a wire? We have learned lambda divided by 2 pi epsilon 0 r. If you go back to your notebook, if you have already attended the classes videos, you can see we have written a formula like this one. If you go some few classes back, you can see this formula. Lambda divided. Lambda means what? Lambda means charge by length. Charge is given. Charge by length is called lambda. We can substitute all the values will be here. So what is the value of charge will be given? It is a negative charge. So minus 4.2 into 10 power minus 7. It's given. Length is how much? Length is 2.4 meter. So we don't want to convert it. It's in meter itself. So we have another value. What are the another values we have? Lambda 0. Lambda 0 you know 8.85 into 10 power of minus 12. R radius value you know 4.6 into 10 power of minus 3. So you have to substitute all the values. So we will go for E for root. E for root will be equal to this value we will substitute minus 4.2 into 10 power minus 7 whole divided by 2.4 whole divided by 2 into pi 3.14 into 8.85 into 10 power of minus 12 epsilon 0, and this value is multiplied with radius 4.6 into 10 power minus 3. Okay, so 2 pi. You have to take some time to solve this calculations. I already solved this value, and this is approximately 6.7 into 10 power of 5 Newton per F is equal to QE. So Newton per Coulomb minus, because of this minus will be there. 6.7 into 10 power of 5. Do not take a calculator. Do not use your mobile phone to solve these values. You write it and you solve it manually, because for if you're going for Neet or IIT JEE, any entrance examination, calculators are not at all allowed. So definitely if you are using your handset, your mobile phones, and if you are using your laptop, please do not use the calculator inside your mobile phone or inside your laptops or PCs, wherever so you are watching these videos. But please solve it manually, then only your mathematical skills will increases, your calculation skill will get increases. So you will get this answers for this one. Okay, so do not use the calculators. Okay, so please try to use, yeah, as I told before, the handwrittens, your normal methods. So we'll move to the next question, question number 44. Okay. Okay, question number 44. Okay, a hollow insulated conducting sphere is given a positive charge 10 microcoulomb. What will be the electric field at the center of the sphere if its radius is 2 meter? Hollow sphere. Okay, hollow sphere means what? Hollow sphere means inside it is empty. If it is hollow sphere and we have given 10 microcoulomb of charges into this one. So hollow sphere means we have learned two things. We have learned, hope you remember this concept, we have learned hollow sphere and we have learned about solid sphere. Okay, for hollow sphere, and this will have different names, right? Conducting sphere, and another name is called spherical shell. This is also called a solid non-conducting sphere. These are the different names. So these two category already we have seen. In case of a spherical shell, if you are plotting the graph between electric field and distance, here also we are plotting the graph between electric field and distance. This I already discussed in the class, but still I am repeating once again so that it will be a refreshment for you. So in case of a spherical, there is no electric field. This I plotted a graph for a hollow sphere, or also called conducting sphere or spherical shell, or for a non-conducting sphere. So the electric field intensity inside a hollow sphere is 0, because inside there is no charges. We already described the detailed theory in the previous videos. So there is no electric field inside, only at the surface and outside. This is a surface point. But in case of a non-conducting sphere or a solid sphere, okay, means if it is filled inside it is not empty, then electric fields are present inside and surface and outside. So in our question it is given electric field. What will happen to this electric field for a spherical shell or a hollow sphere? Hollow sphere means there is no charges are present, hence answer to this question is 0, which means your option A is the right answer for this question number 44. Okay, we'll move to the final question 45. The last question describes about question number 45. The last question 45, final question. A charge Q is enclosed by a Gaussian spherical surface of radius r. If the radius is doubled, then the outward electric flux will be. Okay. Okay. So Flux means what? What is the basic definition of flux? Flux means number of electric field lines per unit area. Okay, number of electric field lines per unit area. Suppose, let me take an example. Suppose I placed one Q will be here. Suppose I am assuming 4 lines are going out, 4 electric field lines are going out like this one. So I can say as an example, flux will be equal to 4. Now I make the radius to be bigger one, a bigger sphere, but I place the same charge will be here. Okay, so the electric field lines are going out like this one. So here radius is small, but here radius is bigger. Here I can say radius is small. Here I can say radius is bigger. So if you are taking smaller radius or bigger radius, any change in the electric flux are happening? No. Electric flux will always indicate number of field lines passing. If you are taking 1 meter square area like this, if you are taking 1 meter square area will be like this. Within 1 meter square area, number of electric field lines are passing. So flux will be equal to number of E lines, electric field lines per unit area. Means in 1 meter square how many flux lines are there, that is called electrical flux. It is not depends upon how much it is bigger or smaller. No, 1 meter square area how many lines. Okay, so that is only depends upon how many charges are present inside. If you are placing one charge here, if you place the same charge here in a bigger sphere, your effect will be the same. So answer to this question is C is the right answer for the question, which means electric flux remains same. Okay, so I done with the chapter with my best level. Hope you understand the theory. Lot of things will be there in the chapter as like comparable to other chapters in the physics. This is a little bit a bigger chapter. Okay, so I will give you a small inputs to help you study. Electrostatics is an important chapter, especially for JEE main and for Neet entrance examination. There is no doubt in that. For both examination, this is really important. That is first point. You are not supposed to skip this chapter anyway for your, even for your what can I say, for your board examination as well as for your entrance examination also not supposed to skip. So what you want to do next one is you have to thorough with all the videos whatever we have discussed for the electric charges and electric field. You should be very thorough with all the videos. You should have a very perfect class lecture notebook with you. First point. Second point, you have to go with this classroom lectures and as well as the discussion question. 45 questions we have discussed which are touching some in and around of the chapter, but still there are enormous number of possibilities are there to ask the questions in a different way. So it is not limited to this one. Next, your duty is like whatever the questions are coming to you from a different sources, you have to learn it. You have to learn it in the sense you have to practice it. Next one is first your aim is you have to learn my notebook thoroughly. I am sure that if you learn this one, you can perform better in the examinations. And in addition to this one, to achieve this criteria, you have to practice as many questions from this chapter. So definitely you will come across different things. So that you have to learn from the mistakes and correct it and go ahead. This is an important chapter. Next point is like you have to maintaining a formula book. I don't know whether I told to you or to in other videos also. I didn't remember exactly, but anyway I'm telling it now in case if I'm not to miss that. So you have to maintain a separate notebook, a small kind of notebook, not big, a bigger one. So in that notebook, while you are learning from one chapter, you are going through the notebook, you will come across lot of formulas we have learned. So just write one line of statement and write one formula. So that book will contain like just like if you have completed electric field and electric charge intensity, I mean the electric charge and electric field intensity chapter, if you are completed, like 2 to 3 pages notebook will be there. I mean within the notebook 2 to 3 pages you have written only with the major important formulas. Major important means all the formulas are important. In entrance examination, nothing called like important, unimportant, no, nothing. All are important. So what you want to do here means you have to write with all the formulas in the notebook. This will be really helpful just 1 day or 2 day or 3 day before the final examination. If you're going, if you want to revise it, it will be pakka and perfect. It will be there in the mind. So my humble request to you is that learn my notebook, whatever the lectures video we have written. First point. Second point, practice as many questions as you can from various resources are available with you and with what I can provide. So you can practice those questions. Second stage. And the third one is write a formula book for each of the physics chapters, so that while you are learning that you can note down the formula. So you have your final formula book will be is like a small book, and that will be your Bible for the physics to crack your entrance examination. So this chapter is over. I done my best level and you do your best level, so that we can crack the questions coming for the upcoming examinations also. Okay, so next class I will come up with the continuation of this one, the next chapter in the Ncert textbook, capacitance and electrical potential, and we will see you. So thanks and have a great rest of the day. Bye bye.